ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರ. ನನ್ನ ಹೆಸರು ಸ್ಮಿತಾ ಪಾಟೀಲ್ GH. ನಾನು ಗೌರ್ಮೆಂಟ್ PU ಕಾಲೇಜ್ ಚನ್ನಗಿರಿ ಇಲ್ಲಿ ಫಿಸಿಕ್ಸ್ ಲೆಕ್ಚರರ್ ಆಗಿ ವರ್ಕ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ನನಗೆ ಈ ಸಕ್ಷಮ ಪ್ರೋಗ್ರಾಮ್ ಅಲ್ಲಿ ಅಸೈನ್ ಮಾಡಿರುವಂತ ಚಾಪ್ಟರ್ಸ್ ಅಟಮ್ಸ್ ಅಂಡ್ ನ್ಯೂಕ್ಲಿಯೈ. ಆಟಮ್ಸ್ ಅಂಡ್ ನ್ಯೂಕ್ಲಿಯೈ. ಇದರಲ್ಲಿ ಫಸ್ಟ್ ಆಟಮ್ಸ್ ಅನ್ನ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ನಿಮ್ಗೆ ಆಲ್ರೆಡಿ ಗೊತ್ತಿದೆ ಆಟಮ್ಸ್ ಅಂದ್ರೆ ಏನು, ಅದರ ಕಾನ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಏನು, ಆಟಮ್ ಮಾಡೆಲ್ ಯಾಕೆ ಬೇಕು, ಫಸ್ಟ್ ಪ್ರಪೋಸ್ ಮಾಡಿದಂತಹ ಆಟಮ್ ಮಾಡೆಲ್ ಯಾವುದು, ಅದರ ಡ್ರಾಬ್ಯಾಕ್ಸ್ ಏನು ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ಮತ್ತೆ ರಿವಿಷನ್ ಮಾಡೋದು ಬೇಡ, ಡೈರೆಕ್ಟ್ ಆಗಿ ಇಂಪಾರ್ಟೆಂಟ್ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ನ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಹೋಗೋಣ. ಅದರಲ್ಲಿ ಫಸ್ಟ್ ಒನ್ ರುದರ್ಫೋರ್ಡ್ಸ್ ಆಲ್ಫಾ ಪಾರ್ಟಿಕಲ್ ಸ್ಕ್ಯಾಟರಿಂಗ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್. This is also known as Geiger-Marsden alpha particle scattering experiment. ಈ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಅಲ್ಲಿ ಹೈ ಎನರ್ಜಿ ಆಲ್ಫಾ ಪಾರ್ಟಿಕಲ್ಸ್ ಅನ್ನ ಥಿನ್ ಗೋಲ್ಡ್ ಫಾಯಿಲ್ ಮೇಲೆ ಇನ್ಸಿಡೆಂಟ್ ಮಾಡ್ತಾರೆ. ಹೀಗೆ ಥಿನ್ ಗೋಲ್ಡ್ ಫಾಯಿಲ್ ಮೇಲೆ ಇನ್ಸಿಡೆಂಟ್ ಮಾಡಿದಂತಹ ಆಲ್ಫಾ ಪಾರ್ಟಿಕಲ್ಸ್ ಡಿಫ್ರೆಂಟ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಸ್ಕ್ಯಾಟರ್ ಆಗುತ್ತೆ. ಹೀಗೆ ಡಿಫ್ರೆಂಟ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಸ್ಕ್ಯಾಟರ್ ಆದಂತಹ ಆಲ್ಫಾ ಪಾರ್ಟಿಕಲ್ಸ್ ಅನ್ನ ಕೌಂಟ್ ಮಾಡ್ತಾ ಹೋಗ್ತಾರೆ. ದಟ್ ಮೀನ್ಸ್ ದೆ ಸ್ಟಡಿಡ್ ನಂಬರ್ ಆಫ್ ಆಲ್ಫಾ ಪಾರ್ಟಿಕಲ್ಸ್ ಸ್ಕ್ಯಾಟರ್ಡ್ ಆಸ್ ಅ ಫಂಕ್ಷನ್ ಆಫ್ ಆಂಗಲ್ ಆಫ್ ಸ್ಕ್ಯಾಟರಿಂಗ್. ಈ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಅಲ್ಲಿ ಅವರು ಒಂದು ಥಿನ್ ಗೋಲ್ಡ್ ಫಾಯಿಲ್ ನ ತಗೊಂಡ್ರು. ಅದರ ಥಿಕ್ನೆಸ್ 2.1 into 10⁻⁻7 ಮೀಟರ್ ಇತ್ತು. ನೆಕ್ಸ್ಟ್ ಅದ್ರ ಮೇಲ್ಗಡೆ ಆಲ್ಫಾ ಪಾರ್ಟಿಕಲ್ಸ್ ಅನ್ನ ಇನ್ಸಿಡೆಂಟ್ ಮಾಡ್ತಾರೆ. ಅದರ ಎನರ್ಜಿ 5.5 MeV ಆಗಿತ್ತು. ಹೀಗೆ ಇನ್ಸಿಡೆಂಟ್ ಮಾಡಿದಂತಹ ಆಲ್ಫಾ ಪಾರ್ಟಿಕಲ್ಸ್ ಡಿಫ್ರೆಂಟ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಸ್ಕ್ಯಾಟರ್ ಆಗುತ್ತೆ. Next, observations of the experiment. Observations of the experiment. In this experiment, they observed that most of the alpha particles, that means 99.86% of alpha particles passes through the gold foil without any deflection. That means theta equal to 0. Next, they observed that 0.14% of alpha particles scatters through an angle more than 1 degree. That means 0.14% of alpha particles scatters through an angle more than 1 degree. Next, they observed that 1 in 8,000 alpha particles scatters through an angle more than 90 degree. That is 1 in 8,000 alpha particles scatters through an angle 90 degree. Finally, they observed that 1 in 10 lakh alpha particles scatters through an angle equal to 180 degree. That is 1 in 10⁶ alpha particles scatters through an angle equal to 180 degree. On the basis of all these observations, they plotted a graph of number of alpha particles scattered as a function of angle of scattering. That means number of alpha particles scattered versus angle of scattering. They took number of alpha particles scattered in y-axis and angle of scattering in x-axis. The nature of graph is like this. Again, on the basis of all these observations, they presented a formula for number of alpha particles scattered through an angle theta, that is equal to k into z square by sine to the power 4 theta by 2. Here K is proportionality constant. Z is atomic number of gold, and theta is angle of scattering. Angle of scattering. Okay, from this equation, it is clear that n of theta is directly proportional to square of the atomic number and inversely proportional to fourth power of the sine of the angle theta by 2. Again, Z is constant for gold. It is constant for gold. Therefore, we can write as n of theta is inversely proportional to fourth power of the sine of the angle theta by 2. This is very, very important relation. This gives the relation between number of alpha particles scattered as a function of angle of scattering. Okay, next. Clear. Conclusion of the experiment. Conclusion of the experiment. This gives the explanation. Explanation for large angle scattering. Large angle scattering means theta is equal to 180 degree. In this case, alpha particle retraces its initial path. Retraces its initial path. That means alpha particle rebounds back. In case of large angle scattering, alpha particle retraces its initial path. This is because of it is experiencing a very large repulsive force that is possible only when entire positive charge and most of the mass of the atom, this is the atom, is concentrated at its center. This central part is known as nucleus. This central part is known as what? Nucleus. Next, electrostatic force of repulsion experienced by the alpha particle due to the presence of nucleus is given by F is equal to 1 by 4 pi epsilon naught 2E into ZE by 4 pi, not that one, by R square. Here 2E is charge of alpha particle, ZE is charge of nucleus, and R is the distance between alpha particle and nucleus. Distance between alpha particle and nucleus. Again, that can be written as F is equal to 1 by 4 pi epsilon naught 2z e square by r square. Alpha particle is a doubly ionized helium atom. It consists of 2 protons and 2 neutrons. Hence, its charge is 2e. Okay, next. Again, the direction and magnitude of this force continuously changes as alpha particle move towards the nucleus and moves away from nucleus. Okay, next, distance of closest approach. Distance of closest approach, that is denoted by capital D or small d, anyone. Again, in case of large angle scattering, as alpha particle move towards the nucleus, its velocity decreases, hence its kinetic energy decreases, but potential energy increases. At a particular distance from the nucleus, its velocity becomes 0 and its kinetic energy also becomes 0. This particular distance of alpha particle from the nucleus, where its velocity becomes 0, is known as distance of closest approach. Then it is rebounds back because of electrostatic force of repulsion due to the presence of nucleus. Okay, next. Here, initial kinetic energy of alpha particles is of mv square, and final kinetic energy obviously 0. Initial potential energy is equal to 0. Final potential energy is equal to 1 by 4 pi epsilon naught 2z e square by d. We know that total energy in an interaction is always conserved. Therefore, total initial energy is equal to total final energy. Therefore, initial Ke is equal to final Pe. Here, of mv square is equal to 1 by 4 pi epsilon naught 2z e square by d. Here we have to calculate for distance of closest approach, that is d. D is equal to 1 by 4 pi epsilon naught 2z e square by of m v square. This is the expression for distance of closest approach. Again, this can be written as d is equal to 1 by 4 pi epsilon naught 2 z e square by k alpha, where k alpha is equal to of mv square. That is the kinetic energy of alpha particles. Next, for the alpha particles of energy is equal to 7.7 MeV. The calculated value of D is, D means distance of closest approach for the alpha particles of energy 7.7 mega electron volts. That is equal to 1 by 4 pi epsilon naught 2z e square by k alpha, that equal to 9 into 10 power 9 into 2. Z is atomic number of gold, that is 79, into E is 1.6 into 10 to the power of minus 19 coulomb square, all divided by K alpha is given, that is 7.7 into 10 power 6 into 1.6 into 10 to the power of minus 19 joules. The calculated value finally becomes 3 into 10 to the power of minus 14 meter. Again, this can be written as 30 into 10 to the power of minus 15 meter. That is equal to 30 Fermi. We know that 1 Fermi is equal to 10 to the power of minus 15 meter. Okay, this is greater than sum of radiuses of alpha particle and that of nucleus. That means 30 Fermi is greater than sum of radius of alpha particle and radius of nucleus. Therefore, the order of size of nucleus is estimated as about 10 to the power of minus 15 meter. This is the radius of the nucleus. Again, we already know that from kinetic theory, the size of the atom, order of size of the atom is 10 to the power of minus 10 meter. Okay, from this, we can conclude that there is 10 power plus 5 meter space is empty in the atom. Therefore, most of the alpha particles, that means 99.86% of alpha particles passes through the gold foil without any deflection. Next, impact parameter. Impact parameter, that is denoted by the letter small b. Impact parameter is the perpendicular distance between initial velocity of alpha particles and nucleus. The trajectory of the alpha particles, that means path followed by the alpha particles, depends on impact parameter. Again, this is the perpendicular distance between initial velocity of alpha particle and nucleus, and its expression is given by B is equal to 1 by 4 pi epsilon naught Z E square by K alpha into cot theta by 2, where K alpha is of mv square, that is the kinetic energy of alpha particles, theta is angle of scattering. Angle of scattering. Okay, this is very, very important relation for impact parameter. Okay, this also can be written as B is equal to D by 2 cot theta by 2. Here, D is distance of closest approach. Distance of closest approach. Next, we can analyze this one. Case 1, we already know that the trajectory, that means path followed by the alpha particle, depends on impact parameter. If impact parameter is 0, then cot theta by 2 is also 0. If impact parameter is 0, cot theta by 2 is also 0. We know that cot function is 0 for 90 degree. Therefore, here theta is equal to 90. It implies theta by 2 is equal to 90. That can be written as theta is equal to 180. Cot function is 0 for 90 degree. Therefore, theta by 2 equal to 90. Then theta equal to 180. This is large angle scattering. Large angle scattering. In this case, alpha particles rebound back. That means they retraces their initial paths. Okay, this is also known as head-on collision. Head-on collision. Therefore, the number of alpha particles undergoing head-on collision are less. ಈ head-on collision ಅಲ್ಲಿ ಇರುವಂತ alpha particles less ಆಗಿರುತ್ತೆ. Next case B. Case 2, that is B, is equal to infinity. For large impact parameter, cot theta by 2 is also infinity. If B is equal to infinity, cot theta by 2 is also infinity. Cot function is infinite for 0. Therefore, theta by 2 is equal to 0. Here, theta equal to 0. For large impact parameter, the alpha particles passes through the gold foil without any deflection. Okay. ಈ ಎಲ್ಲ ಅಬ್ಸರ್ವೇಷನ್ ಇಂದ ರುದರ್ಫೋರ್ಡ್ ಒಂದು ಆಟಮ್ ಮಾಡೆಲ್ ಅನ್ನ ಪ್ರೆಸೆಂಟ್ ಮಾಡಿದ್ರು. ದಟ್ ಇಸ್ ರುದರ್ಫೋರ್ಡ್ಸ್ ಆಟಮ್ ಮಾಡೆಲ್. Rutherford's atom model. According to this model, according to Rutherford's atom model, all the negatively charged electrons revolve around the positively charged nucleus in circular orbits like that of planets around the sun. Therefore, this Rutherford's atom model is also known as planetary model of atom. Okay, in this Rutherford's atom model, he explains that negatively charged electrons revolve around the positively charged nucleus in circular orbits with some velocity. Okay, the necessary centripetal force for the revolving electron around nucleus is provided by electrostatic force of attraction between the positively charged nucleus and negatively charged electron. That is, Fc is equal to Fe. Here, centripetal force needed for the electron is provided by electrostatic force of attraction between electron and nucleus, positively charged nucleus. Therefore, here mv square by r is equal to 1 by 4 pi epsilon naught E into Ze by r square. E into Ze means Ze square. Ze square. Here, m is mass of electron. Mass of electron. V is velocity of electron. R is radius of circular orbit. Radius of circular orbit of electron. Here R get cancelled. Here R power 1 is remaining. It is clear that from this it is clear that mv square is equal to 1 by 4 pi epsilon naught z e square by r. From this again it is clear that r is inversely proportional to v square. The radius of the circular orbit in which electron is moving is inversely proportional to square of the velocity of the electron. Okay, next. Electron possesses both kinetic energy and potential energy. It possesses both kinetic energy and potential energy. Kinetic energy is due to the motion and potential energy is due to charge. Kinetic energy is equal to, kinetic energy is represented by K, that is equal to half mv square. Therefore, K is equal to, in previous we observed that mv square is equal to 1 by 4 pi epsilon naught z e square by r. From this it is clear that K is equal to 1 by 8 pi epsilon naught z e square by r. This is the expression for kinetic energy. Next, potential energy. U is equal to minus 1 by 4 pi epsilon naught z e square by r. Okay, this is expression for potential energy of electron, which is revolving around the nucleus in circular orbit of radius r. Then total energy is equal to K plus U, that is equal to minus 1 by 8 pi epsilon naught z e square by r. This is total energy of the electron, which is revolving around the nucleus of radius r. Okay, next. Drawbacks of Rutherford's atom model. Drawbacks of Rutherford's atom model. It does not explain the stability of the atom. It does not explain stability of the atom. And again, it does not explain the origin of spectral lines. Does not explain the origin of spectral lines. These are the drawbacks of Rutherford's atom model. Next, we can move for spectrum. Spectrum. We already know that what is meant by spectrum. What is meant by spectrum? It is an orderly arrangement of radiations according to their wavelengths or frequencies. That is known as spectrum. There are three types of spectrum. First one is line spectrum. Second one is band spectrum. Third one is continuous spectrum. Continuous spectrum. First, we can discuss line spectrum. Line spectrum. This line spectrum is also known as atomic spectrum. Atomic spectra. Okay. Again, there are two types in line spectra. First one is line emission spectra. Second one is line absorption spectra. Line absorption spectra. When atomic gases or vapors are excited by means of giving energy, they emit radiations of particular wavelengths. Those particular wavelengths looks like sharp, bright lines in a dark background. These are known as line emission spectra. Hydrogen, helium, sodium vapor lamp, sodium vapor lamp, and mercury vapor lamp. Mercury vapor lamps can give line emission spectra. In this, again, we can discuss in detail hydrogen spectra. Hydrogen spectra. Usually, the atoms of hydrogen are at ground state at room temperature. When we supply energy, they absorb energy and excite to the higher energy state, depending upon the energy absorbed. After short interval of time, 10 to the power of -8 seconds, they fall back to the lower energy levels by emitting photons. By emitting photons. That means radiations. These radiations or photons looks like sharp, bright lines in dark background. Therefore, it is known as line emission spectra of hydrogen. The wavelength and frequency of these photons and radiations are not same. Wavelength are not same. Wavelength of all the photons are not same. That means unequal. Frequency also not same. Therefore, we can see the series of spectral lines of hydrogen. That means there are number of spectral series we can observe in hydrogen spectra. In that, first one is Lyman series. Lyman series. Lyman series of hydrogen wavelength ranges from 91 nanometer to 122 nanometer. Therefore, it lies in ultraviolet region. Ultraviolet region. Second one, Balmer series. Balmer series. Its wavelength ranges from 365 nanometer to 656 nanometer. Therefore, it lies in visible region. Visible region. Next, third one is Paschen series. Paschen series. Its wavelength ranges from 820 nanometer to 1875 nanometer. Therefore, it lies in infrared region. That means IR region. These are the spectral series of hydrogen. These are having different wavelengths, different frequencies. Therefore, we can't get a coherent beam of light from hydrogen spectra. Okay, next, line absorption spectra. Line absorption spectra. When white light is passed through a atomic gas, uh, and it is viewed through a spectrometer, we can see dark lines. Those dark lines corresponds to the absorbed wavelengths, absorbed waves from gas. Solar spectrum is example for line absorption spectrum. We know that sun has nucleus that is incandescent, that can emit white light, that is known as photosphere. And this nucleus of sun is surrounded by cooler envelope that consists of vapors of some elements. This is known as chromosphere. When white light passes through this cooler envelope, some waves are absorbed. These absorbed waves looks like dark lines in over the continuous spectrum. These dark lines are systematically studied by scientist Fraunhofer. Therefore, those are called as Fraunhofer lines. In solar spectrum, there are number of Fraunhofer lines. Those are superimposed on continuous spectrum. Therefore, solar spectrum is known as line absorption spectrum. That means solar spectrum is example for line absorption spectrum. Okay, this is about line spectra. Next, we can discuss band spectra. Second one, band spectra. This is also known as molecular spectra. When molecular gases are excited by means of giving energy, they emit bright bands. Those bright bands consist of large number of closely spaced spectral lines. These large number of closely spaced spectral lines are due to the atomic rotational and vibrational emission of energy. That is known as what? Band spectrum. Nitrogen spectrum is example for band. First one, band emission spectra. I am discussing now band emission spectra. Again, there are two types in band spectra. First one is band emission spectra. Second one is band absorption spectra. That means band spectra are due to the rotational and vibrational energies of atoms which are present in the molecules. Band absorption spectra. When white light is passed through the molecular gases, they absorb bands of wavelengths. That means group of wavelengths. They appear as dark bands. Those are called what? Band absorption spectrum. Iodine, chlorophyll can give band absorption spectra. Next one, third one is continuous emission spectra. Continuous spectra. Continuous spectra. Again, there are two types of continuous spectra. First one is continuous emission spectra. Second one is continuous absorption spectra. When dense gases or solid bodies are heated up to a very high temperature, they can emit radiations which are having a wide range of wavelengths ranging from UV to IR without any spacing. Those are known as continuous emission spectra. Incandescent bulb next oil flame, next candle flame, and white hot bodies can give continuous emission spectra. Next, continuous absorption spectra. When white light is passed through colored solutions or colored glasses, they absorb most of the colors completely. Those are known as continuous absorption spectra. For example, when white light is passed through blue colored glass, it absorbs all the colors except blue. This is example for continuous absorption spectrum. Again, when white light is passed through copper sulfate solution, we can see only green and blue colors. Other yellow, orange, red are completely absorbed. Therefore, this is also example for continuous absorption spectrum. I hope you understood all these spectrums very well. Okay, next topic is Bohr's postulates. Bohr's postulates. We know that electrons in an atom revolves only in stable stationary orbits around nucleus without emitting any radiant energy. Second one, they revolve only in those orbits whose angular momentum is equal to integral multiple of h by 2 pi. And third one is they can make transition from any higher level to lower level. That means higher energy orbit to lower energy orbit by emitting a photon whose energy is equal to energy difference between those two levels. Here nu is the frequency. This is known as Bohr's frequency rule. Bohr's frequency rule, and this is known as Bohr's quantization rule. These are the postulates of Bohr's atom model. Next, radius of the nth orbit of the electron in an atom. That is equal to epsilon naught n square h square by pi m z e square. This can be written as Rn is equal to n square by z a naught. Here a naught is equal to 0.53 angstrom. This is corresponding to the radius of first orbit of hydrogen atom. This is known as Bohr's radius. Bohr's radius. Okay, next. Velocity of electron. Here, Rn is directly proportional to square of the principal quantum number. Okay, next, velocity of electron in nth orbit of atom. Here Vn is equal to Ze square by epsilon naught to epsilon naught nh. Vn is equal to Z by n into V naught. Here V naught is equal to E square by 2 epsilon naught h, that is equal to 2.2 into 10 to the power of 6 meter per second. This is the velocity of electron in first orbit of hydrogen atom. Okay, next. Energy of the electron. Total energy. Total energy of electron in nth orbit. Nth orbit. Again, in this, velocity is inversely proportional to principal quantum number n. Here En is equal to minus m z square e to the power of 4 by 8 epsilon naught square n square h square. Again, En can be written as minus z square by n square m e to the power of 4 by 8 epsilon naught square h square. By substituting the values of m, e, epsilon naught and h is given by En is equal to minus z square n square 13.6 eV in electron volts. In joules, it is equal to 2.18 into 10 to the power of minus 18 joules. In EV, that is equal to 13.6. Here, En is inversely proportional to n square. Here, as n increases, energy also increases. This is because of it is negative value. Negative value shows the electrons are bounded to the nucleus, bounded to the atom. If we have to remove electrons, we have to apply energy. Okay, next. Kinetic energy. We know that kinetic energy is equal to minus E. Therefore, kinetic energy is equal to plus z square by n square into 13.6 eV. Again, this En can be written as minus z square by n square m e to the power of 4 by 8 epsilon naught square h square into Hc by Hc. Here, this can be written as R, that is Rydberg's constant, RHC. R is Rydberg's constant, whose value is equal to 1.097 into 10 to the power of 7 per meter. This is what? Rydberg's constant. This is also very, very important equation. Again, this Ke can be written as Ke, or K can be written as Z square by N square, RHC. Next, potential energy U is equal to minus 2E. Therefore, U is equal to minus 2 into minus, not minus, this is plus, minus Z square by N square, 13.6 EV. Then U is equal to minus Z square by N square, 27.2 EV. This also can be written as U is equal to minus Z square by N square, 2 RHC. This is what? Potential energy of the electron, which is revolving around the nucleus in its orbit of radius R. Okay, next. Time period of revolving electron. Time period of revolving electron in nth orbit. That is equal to, we know that time period is equal to 2 pi r. That means circumference of the orbit and velocity of the electron in orbit. By substituting the values of Rn and Vn, we can get Tn is equal to 4 epsilon naught square n cube h cube by m into z square e to the power of 4. Therefore, here Tn is directly proportional to n cube. Next, again, frequency of revolution. Frequency of revolution of electron in nth orbit. In nth orbit is, we know that frequency is inversely proportional to, not inversely, that is equal to reciprocal of time period, that is Fn is equal to 1 by Tn. Therefore, Fn is equal to m z square e to the power of 4 by 4 epsilon naught square n cube h cube. Here, Fn is inversely proportional to n cube. This is also important relation. Okay, next. The orbit of electron is considered as current loop because it possesses magnetic dipole moment. Therefore, its magnetic dipole moment mu is given by, that means magnetic dipole moment of electron in nth orbit is, that is equal to EVR by 2. Mu is equal to E by 2m into mvr, that is equal to mu equal to E by 2m L. Here, L is equal to NH by 2 pi. Therefore, mu is equal to E by 2m into NH by 2 pi. Mu means magnetic dipole moment of the electron is equal to NEH by 4 pi m. For first orbit, that is n is equal to 1, mu is equal to EH by 4 pi m, that equal to 9.27 into 10 to the power of minus 24 ampere meter square. This is known as Bohr's magneton. Bohr's magneton. Again, the gyrometric ratio that is the ratio of magnetic dipole moment to angular momentum, that is nu by L is equal to E by 2m. This is the gyrometric ratio, which gives the ratio of magnetic dipole moment to angular momentum of the electron in nth orbit. Okay, next. When electron makes transition from any higher state to, that means any higher orbit to lower orbit, it emits radiation or spectral lines, that means photons. Number of radiations or spectral lines emitted by the electron during the transition from any higher state into ground state is given by n is equal to n minus 1 by 2. This is the number of spectral lines or radiations emitted by electron during its transition. From n to 1. Okay, that is n is equal to n into n minus 1 by 2. Next, energy level in hydrogen atom. Energy level diagram for hydrogen atom. We know that energy of electron in nth orbit is equal to minus z square by n square into 13.6 eV. Z is equal to 1 for hydrogen. Therefore, En is equal to minus 13.6 by n square. For first orbit, n is equal to 1. Therefore, E1 is equal to minus 13.6 eV. Similarly, for n is equal to 2, E2 is equal to minus 13.6 by 2 square, that is equal to minus 3.4 eV. Similarly, E3 is equal to minus 1.51 eV. E4 is equal to minus 0.85 eV, and E5 is equal to minus 0.54 eV. Again, for n is equal to infinity, E infinity is equal to 0. This is maximum energy. This corresponds to free electron. That means unbound electron. That means ionized electron. It is completely, which one? Electron is completely removed from the atom. for this energy, and least energy is minus 13.6. This is the least energy of electron in hydrogen atom, that is in first orbit. Okay, ನಾಳೆ ಕ್ಲಾಸಲ್ಲಿ ಕಂಟಿನ್ಯೂ ಮಾಡೋಣ.